So the half-life of carbon, of the radioactive isotope carbon-14, is about 5,730 years. The amount of a radioactive element A at time t is given by the formula A sub t equals A sub 0 e to the kt. We need to express the amount of carbon-14 left from an initial n milligrams as a function of time t in years. So we have to find k. All of these exponential problems, you have to find k. To find k, pick a nice number for A sub 0. So we'll just pick A sub 0 equals 100. So we'll say we start with 100 for A sub 0, and then after 5,730 years, we're down to 50. That's what the half-life means. In 5,730 years, half of the initial 100 grams is decayed and become another substance. So we put time as 5,730, and then we solve for k. So first you divide the 100 out. So you have 0.5 equals e to the 5,730k. And then you take the natural log of both sides of the equation. And that lets you use the power rule for logarithms and make your exponent into a coefficient. So natural log of 0.5 equals 5,730 k times natural log of e, and then natural log of e is just 1. So all we have to do is divide both sides of the equation by 5,730, and we have k. So you can leave this exact, depending on what you're doing. This particular problem asks us to round the answer to 6 decimal places, so I'll put this natural log of 0.5 divided by 5,730 in my calculator. So if I put that in my calculator, I have negative 0.0001121. Okay, so that's what k is, and now we have this formula, A sub t equals A sub 0 e raised to the negative 0.000121 t. This particular problem asks us to start with n for A sub 0. So we would write A sub t equals n e to the negative 0.000121 t. Let's look at the second part of this problem. What percentage of the original amount of carbon-14 is left after 10,000 years? So we have our A sub t equals A sub 0 e to the negative 0.000121 t, and 10,000 years have passed. So let's pick a nice number for A sub 0 again. So I'll just say 100. And go ahead and see how much that 100 becomes after 10,000 years. So we'll put negative 0.000121 times 10,000 as the exponent on e and times that by 100. When you put that in your calculator, you get 29.82. So that means your original 100 grams has deteriorated to 29.82 grams. So there's only 29.82% of the original carbon-14 remaining. So that's the answer for the first part. Now the second part, if an old wooden tool is found in a cave and the amount of carbon-14 present is only 47% of the original, how old is the tool? So we're using this starting equation again, but this time we're going to put 47 grams for the final amount and 100 grams for the starting amount, because we went from 100 to 47 grams. Or any other numbers that make 47% on the left. So divide out the 100 and we have 0.47 equals e to the negative 0.000121 t. And take the natural log of both sides of the equation. And you can go ahead and use your power rule for logarithms. So we have natural log of 0.47 equals negative 0.000121 t times natural log of e, and then the natural log of e is just equal to 1. So we'll divide out our negative 0.000121 and find t. When you divide that in your calculator, you'll get 6,239.9 years.